So we're going to try a couple problems using substitution to find the solution to a system of equations. I can tell this one is set up for substitution because this y right there is all by itself. And I know that y is the same thing as 3x plus 8, which means in this bottom equation, I can replace y with 3x plus 8. Since I know those two things are equivalent, I can replace it and not change the values of any of the variables. So I'm going to copy this bottom equation, 5x plus 2. Now instead of y, I'm going to replace it with 3x plus 8, close the parenthesis, and then finish copying. So that equals 5. So now we have just one equation, and we only have x's. And since we only have one variable, that means we can actually solve to find the value of x. So if you make a mistake, like let's say you plugged in this 3x plus 8 down here for x, you'll still have x and y in the equation. So that's a good way to check. So here I see an x term and an x term. There's no y terms, so hopefully we're on the right track. Our next step is to distribute. So 2 times 3x and 2 times 8. And then on the left-hand side, I see I have two terms that are like terms. They're both x terms, and they're on the same side of the equation. So I'm going to put those together. 5x plus 6x is 11x, plus 16 equals 5. And then I can subtract 16 from each side. So I'll get 11x equals negative 11. Divide both sides by 11, and we'll figure out x equals negative 1. Now remember, you're not done. That's just the x value where these two lines meet. We still have to figure out the y value. So I'm going to rewrite that top equation. And it doesn't matter, you could plug into the other equation as well, but this one is already solved for y. So now instead of x, I'm going to plug in negative 1 to figure out what the y value is. So in this case, we'll get y equals 5. And really what that means, these two lines, if I were to graph them, would cross at the coordinate negative 1, 5. This is another example of substitution. This one looks a little bit different because both equations have y by itself, but we're going to use the same logic here. I know y is the same thing as negative 2x minus 5, so I can take that 2x minus 5 and I can plug it in for y in the other equation. So 2x minus 5 is the same thing as 6x plus 3. So whenever you have both equations solved for y, like we do right here, really you're just taking the other sides of the equations and setting them equal to each other. So in this case, we have to get the x's to one side, the numbers to the other side. I always start by moving the smaller x value. So I'm going to look at this 2x right here. It's positive, which means I have to subtract 2x from each side. So on the left, we'll have negative 5 equals 4x plus 3. Now we need to get that 3 to the other side, so we're going to subtract 3. So we'll get 4x equals negative 8. Divide both sides by 4, and we'll get x equals negative 2. So that's the x value. Now we got to find y. Does not matter which equation you plug into. I'm going to plug into that bottom equation because I see all positive numbers in that. So y equals 6x plus 3. Instead of x, I'm going to replace it with negative 2. So y equals 6 times negative 2 plus 3. So y equals negative 12 plus 3, which means y equals negative 9. So if I were to graph these two lines, they should cross at the point negative 2, negative 9.